grade 5s. This is chapter 7, Integers and Equations. We went over some basic information about equations in chapter 1, and we went over some basic information about integers in chapter 2. But now we're going to go slightly more in depth, such as section 1, ordering integers. An integer is a natural number, including 0. So what's a natural number? A natural number is everything that's bigger than 0. Or its opposite. Well, actually, no. Everything that's bigger than 0 and is, well, a whole number. You can use a number line to show integers. Opposite integers, such as -4 and 4, are the same distance from 0. For two integers on a number line, the greater integer is further to the right. It's always been like that for number lines. Thing is, instead of using a number line to compare integers, you can also compare integers the normal way, such as without a number line. If it's negative, then it's definitely smaller than positive. If they're two positive integers, well, guys, last time I checked, you're in grade 5. If you don't know how to order positive integers, if you don't know how to order 37 and 10, and you don't know which one's bigger, well then, I mean, you probably had a lot of trouble back in the previous chapters, and in the previous grades too, so yeah. But the thing is, negative integers, well, negative integers, the bigger the number that follows the negative sign is, the smaller the number is. So -10 is smaller than -4. Now, for example, compare -2 and 1. -2 has a negative sign, therefore it will always be smaller than anything with a positive sign. So you can see that 1 is further to the right, but if you completely ignore this, then, well, you still realize that -2 has a negative sign, so it's going to be smaller than 1, which doesn't have a negative sign. So now we're going to do some ordering integers. -7 and -4. Remember what I said about ordering negative integers? The larger the number that follows the negative sign, the smaller the number is. So 7 is bigger than 4, which means that -7 is smaller than -4. 6 and -2. -2 has a negative sign. 6 does not have a negative sign. Therefore, 6 is larger. -4 and 1. 1 isn't negative. -4 is. Therefore, 1 is larger. 3 and 9. Well, 3 and 9, guys, we're in what grade now? 9 is bigger than 3. Everything's positive, so it just follows normal rules. 0 and -8. 0 is bigger than all the negative numbers. 5 and 0. 0 is smaller than all the positive integers, or just numbers. -3 and -2. The greater the number after the negative sign, the smaller the number is. 3 is bigger than 2, so -3 is smaller than -2. -9 and 5. 5 is, well, not negative, so it's bigger. And -7 and -4. Again, sometimes on a worksheet there will be double questions. Sometimes it's a typo. Sometimes it isn't a typo. This is not a typo. Order each set of integers from least to greatest. -6, 13, -18, 5. So we already know that the positive numbers are greater than the negative numbers. And we know that 13 is bigger than 5. So since it's least to greatest, the last two would be 5 and 13. Now what about -6 and -18? Well, 18 is bigger than 6. So -18 is smaller than -6, because that's how negative numbers work. Therefore, from least to greatest, it will be -18, -6, 5, 13. Over here we have 34, negative 38, 37, and negative 33. Now we pick out the positive numbers and we order those first. So the greater one out of 34 and 37 would be 37. Now, what about negative 38 and negative 33? Well, 38 is bigger than 33, which means that negative 38 is smaller than negative 33. Because that's how negative numbers work. The order from least to greatest would be negative 38, negative 33, 34, 37. Here, we have 18, 0, negative 4, and negative 7. Now, I know that 0 isn't exactly positive, but it's not negative either. And there's only one positive integer, which is 18. And then it's 0, and then it's the two negative ones. Negative 7 is smaller than 4, as shown by, well, the questions above. So the order from least to greatest would be negative 7, negative 4, 0, 18. Now, we have 8, negative 19, negative 3, and 37. There's two positive integers, 8 and 37. 37 is larger than 8. And then there's two negative integers, negative 19 and negative 3. Now, 19 is bigger than 3. But the thing is, this is negative. So it's the exact opposite. Negative 19 is smaller than negative 3. So least to greatest would be negative 19, negative 3, 8, 37. Here we have 5, 1, negative 10, negative 4. 5 and 1 are positive, so then they would be bigger. 5 is bigger than 1. And then negative 10, negative 4. 10 is bigger than 4, but it's negative, so negative 10 is smaller than negative 4. Then there's 55, negative 43, negative 59, and 50. 55 and 50 are positive integers, so they're bigger than the negative integers. And 55 is bigger than 50. 59 is bigger than 43, but this is negative, so instead it would be negative 59 is smaller than negative 43. Least to greatest, it would be negative 59, negative 43, 50, 55. If you want to take some time and absorb some of this information, well, go on ahead. But if you just want to keep moving on, then keep playing. Section 2 is adding integers. Now, adding integers is not the most difficult. So you can use a number line, but I prefer it if you don't. Just no, ignore this. No. Because guess what, guys? High school, they don't give you number lines. And if you have to use a number line, you either draw your own, or the teachers, well, actually, no, they won't actually laugh at you, but like, it's just no. So you know how to add, except if you add negative integers, you move to the left. So adding a negative integer is subtraction. So think about it as, if you say 4 plus negative 6, then it would be equal to negative 2. But it's just 4 minus 6. And here's the thing. If it's 4 minus 6, you know that, well, that doesn't really work because that's less than 0. But now there's numbers below 0. So after it's 4 minus 4, but then there's 2 more than 4, so then it's negative 2. Now here's the rules for adding integers summed up in a nice table. The sum of two integers that are positive is positive. The sum of two negative integers will always be negative. The sum of a positive integer and a negative integer has the sign of the integer further than 0. Technically, it's just, if it's a positive integer and a negative integer, then you use the commutative property, switch it around, and turn it into subtraction. So we're going to do some, well, practice problems. Negative 14 plus 2. Okay, guys. If you want to think about it this way, negative 14 plus 2 is like, you could do it two ways. You could do it as 2 plus negative 14, which is 2 minus 14, which is negative 12. Or you could think 14 minus 2 and put a negative sign on it. Because 14 minus 2 equals to 12, and then you plop a negative sign on it, and it's negative 12, which is the right answer. 3 plus 7. These are both positive integers, so I'm sure you know how to do this. 3 plus 7 is 10. Negative integers. Here's the thing for negative integers. If you add a negative integer, it's just subtraction. What's negative 8 minus 5? Well, think of it as you have dug yourself a hole and you keep digging. You will only get deeper. So it gets more negative. Negative 8 minus 5 is, well, negative sign 8 plus 5, which is negative 13. Now here we have 12 plus negative 6. So 12 plus negative 6 is like 12 minus 6, which is equal to 6. Negative 4 plus negative 2 is again like subtraction, and you end up with negative 6. 10 plus negative 3 is like 10 minus 3, which is equal to 7. Subtraction gets a little bit harder. To subtract an integer, add its opposite. Subtract 5 minus 8. Add the opposite. Use a number line to find 5 plus negative 8. But honestly, don't do this, because I've already shown you. 5 plus negative 8 is even worse. Never use a number line. Just don't. No. If you learn to use a number line, you are going to become reliant on the number line, and then in high school, everybody will laugh at you, because why are you still using a number line? Great, now that I've butchered that enough, 5 minus 8. Here's the thing, if you really need a visual, get this. 2, 3, 4, 5. Okay, that's 5. And then you take off 8. But oh no, there's nothing more. You need to keep digging. So then you dig 1 more, which is 6, 2 more, 7, and then 3 more, which is 8. And then you get negative 3, because you're below ground level now. But it's technically 8 minus 5, and you plop a negative sign on. But here's the annoying part. If you subtract a negative number, okay, you know what? Let me butcher a number line again. This doesn't exist. By the time you get into a higher grade, this doesn't exist. Nobody's going to provide one for you, and if you become reliant on it, well, no. You are going to find yourself meeting a terrible fate. Why does that sound like a line from a video game? It probably is. Note that I am not trying to copy any video game. If there is any similarity to a video game, well, that is unintentional. Here's the thing. If you subtract a negative number, essentially, you're adding that number. So negative 2 minus negative 4 is equal to negative 2 plus 4. Which is, if you need a visual, This is negative 2. You put in 2, and then there's 2 more, so then it's positive again. Why would you add when you're subtracting a negative number? It's like double negative. I know that in a lot of places, well, some places, it says, I ain't doing nothing, means, well, I'm not doing anything. Don't look at me, I'm not doing anything. But if you go up to somebody and say, hey, at least I didn't do nothing, it means that you did something. So double negative makes a positive. Unless it's a dialect. Now, subtract. Negative 8 minus negative 1. So that's a negative number plus 1. Now negative 8 plus 1 would be negative 7. Because you're going up 1. And if you go up 1, it's negative 7. Not negative 9, that's going down. And then we have 8 minus negative 17, which is equal to 8 plus 17, which is 25. Negative 3 minus 3, you're just digging yourself a deeper hole, so that's negative 8. Or if you want to think about it like this, negative 5 plus 3 in brackets. Now, negative 4 minus negative 10. Again, double negative becomes a, well, positive? Yeah, positive. Negative 4 plus 10 is equal to 6. Negative 4 plus 10, if you really want to think about it like this, you could say, okay, I'm going to do it here. Negative 4 plus 10, use a commutative property and you get 10 plus negative 4, which is equal to 10 minus 4. Yeah. That's how you would think about it. And that's where the 6 came from. Now, negative 2 minus 9 is equal to, well, you're digging yourself a deeper hole, so it's just negative 11. Now, we continue. 10 minus negative 6 is equal to, well, double negative makes a positive, so 10 plus 6 is 16. 7 minus 5. They're both positive integers. It's not as if one of them is bigger than the other. Like, by one of them is bigger than the other, I mean 5 minus 7. 5 minus 7 would be, well, negative 2, by the way. But 7 minus 5 is equal to positive 2. Negative 7 minus 7, you're digging yourself a deeper hole, it's negative 14. 6 minus negative 11 is 6 plus 11, which is 17. If you want to pause, do some practice problems, go get a break, go catch a break, go do a break. Okay, there's many different ways that you could say break. You can, but if you don't, and you want to stay here, or if you just came back, we're moving on to multiplying integers. Now, multiplying integers is actually really simple. You multiply like normal. But if the signs of the integers are the same, then the product is positive. If they're different, then it's negative. Say, 6 times 5 is just 30. Negative 7 times negative 2 is still positive. Just plain old 14. But if they're different, then the product is negative. 5 times 18 equals to negative 90. Negative 6 times 2 is equal to negative 12. So you multiply like normal, but the sign depends on whether or not the signs of the integers are different. If the signs of all the integers are the same, then it's positive. Say, negative 2 times negative 3 times negative 4. It's, well, here's the thing. If you do a bunch in a chain, then it depends on the chain. Say negative 2 times negative 3 times negative 4, then it's still going to be negative. Why? Because negative 2 times negative 3 is going to be equal to 6, and then that'd be 6 times negative 4. And that's, well, not the same sign, so it would be negative. But if it was negative 2 times negative 3 times negative 4 times negative 1, then it would be, well, pretend that's a negative sign, guys. That's negative 1, guys. Then it would be positive. Yeah. But for the properties of multiplication, well, they're basically the same. There's a commutative property for multiplication, so A times B equals to B times A. The associative property for multiplication for any integers, A, B, and C, A times B times C is equal to A times B times C. Such as, well, for the first one, it would be 2 times 3 equals to 3 times 2. They're both equal to 6. For this one, it'd be something like 2 times 3 in brackets times 4 is equal to 6 times 4 is equal to 24. And that would be equal to 2 times 3 times 4 in brackets, which would be 2 times 12, which is also 24. Identity property for multiplication is anything times 1 equals to, well, that thing. Such as negative 3 times 1 is equal to negative 3. The zero property for multiplication is anything times 0 equals to 0. Negative 3 times 0 equals to 0. Positive 3 times 0 equals to 0. The distributive property of multiplication over addition, it's, well, like this. B plus C in brackets times A is equal to AB plus AC. AC, air conditioning. Yeah, don't ask. Now we're just going to do some good old multiplication. So 6 times 6, I'm sure we've seen this. It's just classic 36. Negative 4 times 9. You're still going to multiply like normal. So 4 times 9 equals to 36. But these two numbers don't have the same sign. So it's going to be negative. Negative 36. 8 times negative 2. 2 times 8 is equal to 16, but these guys don't have the same sign, so it's going to be negative 16, because negative 2 and positive 8. 3 times negative 8, 3 times 8 is equal to 24, but it's positive 3 and negative 8, so it's going to be a negative sign since it's not the same, or you can't pair it to be the same. Negative 7 times negative 5 is, well, 5 times 7, 35. These two both have the same sign, so it's going to be positive 35. Negative 3 times 12. 3 times 12 is 36, but it's negative 3 and positive 12, so different signs mean negative. Negative 9 times negative 6. Well, 9 times 6, 54. And they're both negative, so it's just going to be positive. 1 times 9, it's positive because, well, they're two positive integers. And they have the same sign, so. Negative 11 times 0. Well, 0. Because anything times 0 equals to 0. 12 times negative 3. It's 12 times 3, 36. But this time, well, it's still going to be negative because negative 3. Negative 10 times negative 6. They're both negative, so it's going to end up as positive. Now 6 times 10 is equal to 60. 8 times negative 5. 8 times 5 equals to 40. There's one positive and one negative, so it's going to be negative. you might be wondering, when are we going to get the division? Well, we aren't, because we're going to do a problem-solving strategy first. Work backward. A naturalist plans to study exotic birds in the rainforest. The helicopter flight to and from the rainforest costs $667. Supplies cost $100 for each day. How many days can the scientist spend in the rainforest on a $2,069 budget? Here's the thing. I'm not sure about actual expedition budgets, but that looks really cheap. Okay, so what do we know? We know how much each thing costs. And we know what the cost is per day. We also know how much money we have in total. What do we need to find? How many days we could stay there with the money that we have. Well, not we. Okay, they didn't mention their gender, so the naturalist has. Now, our strategy has to be work backwards because that's what we are supposed to do. To carry out our plan, $2,069 budget minus cost of helicopter flight to and from is equal to that, and the cost for supplies each day is $100, so the amount of days we could spend is this divided by 100, or at least the closest it gets, is 14 remainder 2. How many days can the scientist spend in the rainforest? 14. Is the solution reasonable? Reread the problem. Have we answered the question? How can we check our answer? We can check our answer by working forward, as we did in the last chapter. Have you answered the question? Yes, we did. Reread the problem to make sure that our facts are correct. Helicopter flight to and from costs $667. Supplies cost $100 for each day. How many days can the scientist or naturalist spend in the rainforest on a $2,069 budget? Okay, we got our numbers correct. And the thing is about, is the solution reasonable, is that sometimes in math textbooks the solution isn't that reasonable. Like, one person can decide to suddenly go out and buy $688 bananas. I mean, I guess if you open a banana bread factory, you could, but in real life, not everybody just decides to go outside and buy 659 bananas. Or 688, which was the number that I just said. Furthermore, not everybody can eat 106 watermelons in one go, unlike some math problems. Remember last chapter when I told you about that one person that ate 120 wrapped candies in one go and somehow managed to not, like, perish and expire at the spot? Yeah. So we're gonna do some good old practice problems. Miss Miller's class is planting trees for Earth Day. They raise a total of $354 to buy trees and supplies. A local nursery has offered to provide trees for $10 each. They spend $36 on supplies. How many trees do they buy? So how do we work backwards? Well, we have the total number of dollars. We subtract the amount that they would spend on supplies, and we get $318. And then we divide that by 10 to find out how many trees they could buy, and it's 31 trees. Because you can't buy 4/5 or 8/10 of a tree. I mean, sure, it's a math textbook, but you still have to have that much common sense. Although there's ridiculous stuff, as I've said, about people buying 80,000 baguettes, you still have to acknowledge that you can't have half a human in your class. So, yeah. 31 trees. Mr. Salieri's class, Salieri reminds me of the classical composer, visits the aquarium. He has $480 for the trip. The entrance fee for the class is $378. The rest of the money is used to buy posters for the classroom. Each poster costs $20. How many posters does Mr. Salieri buy? Okay, here's the thing. If you're saying that $20 for a poster is expensive, trust me, if you try to do any online shopping, all the posters are at least $20. Or somewhere close to $20. And trust me, gift shopped things are expensive. Anyhow, working backwards, total subtract entrance fee, which is a fixed fee, which you can't change. We have $102 left, $20 per poster, which means 102 divided by 20, which is 5, remainder 2, but you can't buy, well, you can't really buy 220s, would be 1/10. 1/10 of a poster? No. Like, what would that even be? A strip? Like, no, just get a poster and cut off. Okay. Yeah, so, rule, you can't really buy fractions of whole things. Just like how if you go to a store or a restaurant and ask for half of a hamburger, they're probably just going to stare at you going like, no. Yeah. 5 posters. Now that we've taken a break from integers, we're going to go back to integers. What are we going to do now? Well, we're going to divide the integers. The division rules for integers are the exact same as the multiplication rules. The signs of the integers are the same, the quotient is positive. If the signs are different, then the quotient is negative. For example, negative 40 divided by negative 5 is just 40 divided by 5, which is 8. And then you say, these are both negative, so it's a positive. 2 negatives make a positive. Yeah. And then 16 divided by 4, they're both positive integers. They're the type of divisions that we've been doing for years already. Therefore, we already know it's just 4. When the signs are different, then it's just like multiplication. You just divide the number bit, and then you look at the signs, and if they're different, then you put a negative sign. 12 divided by 3 is 4, but it's negative 12 and positive 3, so it's negative 4, because the signs are different. 81 divided by negative 9. 81 divided by 9 equals to 9, but one's negative, one's positive, so the signs are different, so it's a negative 9. Now we're going to do some division. You can multiply to check division, but if you're telling me that you can't tell what 10 divided by 5 is, I mean, that would be kind of strange for a grade 5 kid. Anyhow, negative 56 divided by negative 7. 56 divided by 7 equals to 8, and they're both negative, so it's a positive 8. If you really want to check, then you could do negative 7 times 8 equals to negative 56, since the signs are the same. But honestly, as long as we take a good look at the signs and not mess up that bit, along with remember our multiplication tables, we should be fine. 95 divided by 5 is equal to, well, both of those are positive integers, so the answer is going to be positive. 95 divided by 5 is equal to 19. 78 divided by negative 3. One of those is positive and one of those is negative, so the answer is going to be negative. Now, what is 78 divided by 3? Well, it's 26. So the answer would be negative 26. Now, negative 48 divided by 24. One of them is negative, one of them is positive. So the final answer, final quotient, would end up being negative. Since, well, one's negative, one's positive, meaning that the signs are different. 48 divided by 24 is equal to 2. The negative sign's already there, so. Negative 38 divided by negative 2. Both of those have negative signs. And since the signs are the same, then the answer is going to be positive. So 38 divided by 2 equals to 19. And the answer is just going to be positive 19. Oh wow, there's two 19s that are both positive. Nice. 54 divided by 9. But it's negative 54 divided by 9. And negative 54 is, well, negative. And 9 is positive. The signs are not the same, so it's going to have to end up negative. Now 54 divided by 9 is 6. The answer is negative 6. 16 divided by negative 8. 16 divided by 8 is 2. But one's positive, one's negative, which means that the final quotient would be negative 2. Negative 72 divided by negative 9. Both of those are negative, which means that the final quotient would be positive. And 72 divided by 9 is equal to 8. It's just going to be positive 8. Negative 57 divided by negative 19. They're both negative. So, okay, yeah, they are. It does end up being a whole number, whole integer. It's just going to end up as positive. 57 divided by 19 is equal to 3. So the answer is positive 3. Negative 32 divided by negative 4. Both of these numbers are negative. Therefore, the answer ends up being positive. And 32 divided by 4 is equal to 8. 32 divided by 4 equals to 8, which means that the answer is just positive 8. 69 divided by 13. Now this isn't actually divisible. At least it doesn't divide into an integer. So we're gonna just end up with, well, 69 and negative 13. The signs are different, so it's going to end up as negative, and the solution is just going to end up as 69 over 13, which really doesn't divide out. So yeah. 10 divided by negative 5. 10 is positive. Negative 5 is negative. Therefore, the signs are different, which means, well, it's going to end up as negative. And then 10 divided by 5 is 2. The answer is negative 2. Now, of course, if it's something like negative 20 divided by 5 divided by negative 2, I'm just going to tell you this, but the answer is going to end up as positive. Because negative 20 divided by 5, order of operations, we go from left to right, is equal to negative 4. And then negative 4 divided by negative 2, well, the signs are the same, so it will just end up as positive 2. Yeah. It's not so much the signs are different as is there a sign to pair up the sign with. But it is, if the signs are different, then it's going to be negative. At least for this grade, because usually you don't have long trails of division. At least not in grade 5.